Hello everyone. Next topic is cell potential. Cell potential is actually, you can say that the output voltage when the two half cells are connected in a series. Today we are going to define the cell potential and how can we theoretically calculate the cell potential, that means output voltage of a full cell. Okay, so let's start with the topic cell potential. Give your attention everyone. When the two half cells are connected in series, it forms a full cell. And a full cell is always give the output voltage. Clear? So, when the two half cells are connected in series, then the spontaneous flow of current occurs from anode to cathode through external circuit. This spontaneous flow of electron occurs under some electrical pressure or potential. It's known as cell potential of the cell. The cell potential of the cell is also known as electromotive force, that means EMF of the cell. Clear? Okay. Once again, the definition is when the two half cells are connected in series, the spontaneous flow of electrons occurs through the external circuit from anode to cathode under some electrical pressure. This electrical pressure is known as cell potential. Cell potential is also known as EMF of the cell. As electrode potential, that is for the half cell, is denoted by E cell, same way the cell potential is also denoted by E cell. Electrode potential is just the potential of the single half cell, and cell potential is the difference of two half cells which are connected in series. Clear? Once again, electrode potential is actually the potential of the single half cell, and cell potential is the potential difference between two half cells which are connected in series. Clear? Okay. So let's go ahead. Now, if the cells are standard, that means both the half cells are standard, then it's said to be a standard full cell. The cell potential of the standard full cell denoted by E0 cell. Once again, I am telling you, cell potential is the difference of the relative intensity of cathode and anode to lose the electron or to receive the electron. Right? As we discussed, according to the present IUPAC convention, the half reactions are generally written in a form of reduction. So here we are accepting the definition of the cell potential, that is another one definition of the cell potential, in a form of reduction reaction, that means in form of to receive the electron. As we know that anode is experience the oxidation, cathode is experience the reduction. That means the half cell which work as a cathode have a higher tendency to receive the electron than the anode. So if we want to represent the cell potential in terms of the reduction, we have to take a difference of the cathode minus anode. Clear? Why it is cathode minus anode? Because the relative intensity to gain electron of cathode is more than the anode. Clear? Confirm? Okay. So mathematically, E0 cell is equal to the E0 of cathode minus E0 of anode. Once again, I am telling you why it is cathode. Because the cathode experience reduction, that means the half cell which work as cathode have a higher tendency to gain electron. Why we are accepting on reduction here? Because according to present IUPAC conventions, half cell reactions are denoted in form of reduction. So if you want to convert this half cell potential in form of oxidation, then we have to just put a minus sign, because according to electrode potential, the half cell potential, that is work as anode or cathode, that is oxidation reduction half cell potentials, are same in magnitude but opposite in a sign. Clear? This representation is in form of reduction. So what will be the representation of this mathematical form inverse? Then you can say that the cell potential is actually the difference of relative intensity of cathode and anode to receive the electrons. Clear? Mathematically, E0 cell is actually E0 cathode minus E0 anode. It is the difference of relative intensity of the cathode and anode to receive the electron. And to receive the electron, that is a reduction reaction, so it is also known as reduction potential. What it is known as? Reduction potential. Okay. If I want to write down in form of oxidation, then I can write, now just give attention, in form of oxidation, E0 cell is equal to E0 anode minus E0 cathode. Why it's so? Because anode experience the oxidation, cathode experience the reduction. That means the relative intensity to lose electron of the anode half cell is more than the cathode half cell. Okay. In words we can write down in this way. So once again, the cell potential is the difference of relative intensity of anode and cathode to lose the electron. To lose electron, that is called oxidation reaction. So this difference is known as oxidation potential. Okay, for a half cell, remember this thing, and to note down this very important statement, that half cell potential, oxidation and reductions are opposite with the sign but same in magnitude. But in case of the cell potential, it is always positive if it is an oxidation potential or it is a reduction potential. Okay, how can I say this thing? Then just give attention. Once again, note down this thing. I am putting on the board, just give attention and note it down. Third important note is, if for the whole cell E0 cell is less than 00 volt, that means negative, then the half cell considered as anode is actually cathode, and the cathode is an anode. That means the terminals we are considering, anode and cathode, they are actually opposite. Anode is cathode and cathode is anode. Okay, so these three important points, note it down for numerical as well as for the MCQs. These points are very important. Once again, the half cell, for the half cell, oxidation reduction potentials are numerically equal but opposite with the sign. For full cell, the cell potential in terms of is positive and same in magnitude as well as with the sign also. If for the full cell, if E0 cell is less than 00 volt, that means negative, then the half cell considered as an anode is actually cathode and cathode is actually anode. Clear? Confirm? Okay, right now. The topic is continue in a next board work. How can we identify the given potential is oxidation or reduction, and how can we calculate the full cell potential? Okay, topic is continue.